Hey everyone, it's Mrs. Mers here to help you with problem set for lesson 10. So we're going to make our own rules for how to solve these problems. We're still going to be solving in two different ways. We're going to be using the area model and the standard algorithm to solve our multiplication problem. This time you can tell that our problems look a little different because now they have decimals. But I don't want you to worry about a thing because actually, this is something that we've done in the past, and we're going to kind of pretend that the decimal points aren't even there until the very end. So let's go ahead and look at our first problem. Ignore the directions that are given on the problem set here. I would just like you to do exactly what I'm going to do. We are going to not estimate, we are just going to solve using the two different ways. So the first way we're going to solve is with our area model. Remember that your area model is a box. And I want you to forget about the decimal for now. So really the problem that you're solving is going to be 22 times 24. Forget about the decimal point for this moment. You know how to do this area model. 22 is broken up into 20 and 2. 24 is broken up into 20 and 4. We know that 2 times 2 is 4 with 2 zeros. 20 times 2 is 4 with 1 zero. 4 times 2 is 8 with 1 zero. 4 times 2 is 8. You can solve using your partial products. 400 plus 40 is 440. And 80 plus 8 is 88. And when you add those two together, 8, 9, 10, 11, 12, you have 528. Now here's where you have to look back at the problem as to where the decimal point is. In my original problem, I have 2.4 is my decimal, 2.4. And what I'm going to do is I'm going to count over how many decimal points, how many digits are to the decimal. So I count over that it is one hop over to the decimal point. You're going to do the same thing for your answer. Oh, I don't know what happened there. Sorry, guys. All right. You're going to do the same thing for your answer. You're going to go over one hop and add your decimal point back into your answer. And your answer is 52.8. Let's check our work using standard algorithm. Notice that we're going to completely forget about the decimal for the time being. It is 22 times 2.4. Forget the decimal point is even there. We only use it at the end to see where our decimal goes. Using standard algorithm, we go 4 times 2 is 8. 4 times 2 is 8. Oh, I see my partial product right there. Placeholder as a 0. 2 times 2 is 4. 2 times 2 is 4. Oop, partial product, pretty cool. Add them up. 528. Now I need to check back and see where my decimal point is. It is one hop over, which means in my answer, the decimal point is one hop over. Make sure that you understand how to do both different ways. On tests and on assessments, I'm only going to ask that you show me one way. So if there's one way you feel most comfortable with, then make sure you're very, very good at that method. But do be familiar with both ways at how to do this. Let's try another problem together. All right, moving on to 1B. The problem is 3.1 times 33. Using area model and standard algorithm, we are going to solve. For the area model, we are going to pretend that that decimal is not even there. It is 31 times 33. We know that 31 is broken up into a 30 and a 0. 33 into 30 and 3. Break it apart. 3 times 3 is 9 with 2 zeros. 3 times 3 is 9 with 1 zero. 1 times 30 is 30. 1 times 3 is 3. Add up your first column together. 900 plus 90 is 990. 30 plus 3 is 33. As you add them up, 9, 10, 11, 12, you have 1023. Look back to the original problem to see where that decimal point originally was. It's how many hops over from the back? It's one hop over from the back. 1 hop. In my answer, it's going to be 1 hop over from the back. 102.3 is your answer, your product to the problem. Let's check our work using standard algorithm next. Let me figure this out really quick. All right, make that a little smaller. Here we go. We have 3.1 times 33. Ignore the decimal for now. Just solve it. Just solve it like usual. I made a mistake, so I had to rewind and erase this part. Okay, placeholder as a 0. Go ahead and add it up. You should see your partial products there. Looking good. 1, 0, 2, 3. Looks good to me. Same answer. We're going to go ahead and add back in our decimal point. In the problem, it is 1 hop over. In my answer, it is 1 hop over. Place it in there. We're looking pretty good, boys and girls. You guys, I just had to stop the movie that I was making because I caught Lucy grabbing a bag of spinach out of the garbage. Naughty dog. All right, next problem. 3.2 times 47. Forget about estimating. We are only going to solve using standard algorithm. Go ahead and set your problem up. Leave the decimal in there, but you don't have to worry about it for now. You're just going to solve like a normal problem. Let's make sure we can do our multiplication here. 7 times 2 is 14. Carry the 1. 7 times 3 is 21. And 1 more is 22. 0 as a placeholder. 4 times 2 is 8. 4 times 3 is 12. Add up your partial products. 1,504. But we are not done because this problem has a decimal point in it. Don't forget, it is 1 hop over. In our answer, it is 1 hop over. All right, we are going to go straight to problem number 4, the last problem on here. Skip over some of the other ones. If you have time at the end, you can go back and try some of the other problems. It says a wire is bent to form a square with a perimeter of 16 4/10 centimeters. How much wire do you need to form 25 squares? Express your answer in meters. So I'm going to look at this important information on this word problem. I know that it's important that I know the perimeter of this wire is 16.4, and I need to know that we're doing 25 squares. So I'm going to multiply 16.4. I'm going to give myself a little bit more room. I'm multiplying 16.4 and 25 together. You can just solve standard algorithm for this problem. If that works for you, that's fine for me. No worries there. All right, I'm trying to get rid of this 16.4. There we go. Here we go, solving our problem. 5 times 4 is 20. Place the 0, carry the 2. 5 times 6 is 30, and 2 more is 32. Carry the 3. 5 times 1 is 5, and 3 more is 8. Moving on. Placeholder as a 0. 2 times 4 is 8. 2 times 6 is 12. Put the 2. Carry the 1. Notice how I'm getting rid of that 3 from before. It's gone. 2 times 1 is 2, and 1 more is 3. Add them up. 4100. Now, we need to figure out where to add our decimal back in. It is 1 hop over in our answer, in our problem. It is 1 hop over in our answer. I'm almost done. Because it's a word problem, my answer needs to be in words. And you would need 410.0, or just 410 meters of wire for those 25 squares. Great job, everyone. I'll see you at my center.